Hello and welcome to ChemTube. My name is Jakube Paul. I am your chemistry teacher on this YouTube channel. In today's lesson, we will be looking at the classification of matter. In the previous lesson, we looked at the nature of matter as well as the changes in matter. In today's lesson, we would look at how matter is classified. Basically, like the last lesson, this lesson is going to come in two parts, where we will try as much as possible to cover the classification of matter. At the end of this lesson, it is expected that you would be able to appropriately classify matter. You will be able to define elements, identify them by their elemental symbols, and be able to tell how these symbols were derived. Same thing applies to compounds. Here we start. Matter is basically classified into two broad groups. The first group is known as what? Pure substances. And then the second group is known as what? Mixtures. In today's lesson, our focus is going to be on the first group, pure substances. While in the second part of the classification of matter, we would look at mixtures. We will define mixtures, types of mixtures, we will compare mixtures and compounds, which will be dealt with today. We would look at compounds today. Then, after that, we would also look at technologies or methods of separating mixtures in the second part. Okay? But in today's part, we are focusing on pure substances. So, if you hear the word pure, that something is pure, what comes to mind? Pure, if you ask me, simply implies wholeness. Wholeness. That it is composed of just itself and itself alone. Okay? So, when we want to define pure substances with respect to matter, we can say that a pure substance is any substance that has a definite composition in response to physical changes. Okay? A pure substance is any substance that has a definite, or let me use the word constant, composition. In response to physical changes. To give you an example, let's take a look at gold. We know that gold tends to come in what? Solid form. But we know that gold can be subject to what? Melting, which is one of the examples of the physical changes we gave last time. In the last lesson, we said that an example of a physical change is what? The melting of ice or candle wax. So gold falls into the category of solids that can be subject to melting. But when you melt that gold and it changes state from solid to liquid, the composition remains the same. The properties of gold, the core properties of gold, remains the same. That is the implication of this definition, that it has a definite or constant composition in response to physical changes. Is that clear? Okay. So, having established the definition to a pure substance, what are the classes of pure substances we have? Because we still have categories of pure substances. This now brings us to what? Elements and compounds. Pure substances can be classified into 1. Elements, and then 2. Compounds. And these are what we would be looking at in today's lesson. Okay? Good. If you are asked to define an element, how will you define an element? Let's say you entered for an exam, a chemistry exam, and when you open the question booklet, the first question you see is define element. How will you define element? I'd like to see your definition in the comment section. Okay? Yes, just go ahead and put down your definition. Let's see what you define element to be. But remember, I said that keywords give a comprehensive meaning to any term. Good. So, if I am to define element, I would say that an element is first a pure substance. Okay? Because it is one of the categories or classes of pure substance. It is a pure substance that cannot be chemically separated or splitted into simpler substances. An element is a substance a pure substance that cannot be chemically splitted or separated into simpler substances. Okay? Yeah. So we say an element is a pure substance which cannot be separated into simpler substances. Now, the keywords in this definition are what I wrote in capital letters. Is that clear? Okay. Now, having established the definition of element, what are examples of elements? You are familiar with a lot of elements. For example, we have oxygen, which we breathe in. We have carbon. We have nitrogen. We have phosphorus. We have fluorine. We have neon. We have potassium. We have calcium. In fact, we have 118 elements in the periodic table. The periodic table is the table that contains all of the elements that are in existence. Okay, we would look at the periodic table in one of the subsequent lessons, but we are not looking at it today. So these are examples of elements. Generally, elements are represented with elemental symbols. Elements are represented with elemental symbols. And why is that so? Elements are represented in this manner in order to make it convenient to call or spell these elements' names. Because in some cases, some elements have very long names, and in some cases, these elements have names that are not that easy to pronounce. I'll give you two examples of very long names. I mean, the longest elemental name you have is Rutherfordium, which is a name given to an element in honor of Rutherford. Okay, Rutherfordium. This is an element. So, if you see the name is too long for you to start writing, so instead of going through the time wasting, you just represent it with what? The elemental symbol, which is RF. Another one is Praseodymium, which is represented with what? PR. You see? PR. Okay. So, if you look at these two names, you would notice something, that the first letter is usually a capital letter. Then the second letter is a small letter. Generally, when you are writing the elemental symbols of elements, if it is having just one letter, then that letter is usually a capital letter. For example, your oxygen. This is oxygen. It is represented by letter O. We say carbon. This is carbon. It is represented by letter C. Is that clear? Okay. So, these are as it is. The first letter is usually capital letter for those that have two letters. And in fact, out of the 118 elements in the periodic table, 104 of them are represented with two letters. Only 14 has just one letter as the elemental symbol. Is that clear? Okay. So now, how do we derive these elemental symbols? That is, how are these elemental symbols generally derived? There are 4 ways to derive them. One is the first letter of the elemental name. Like I said, oxygen, okay, we've mentioned oxygen. Let's say hydrogen. Hydrogen, for example, where the symbol, elemental symbol is what? H. Okay, let's say sulfur, where it is what? S. That is it. Okay, for number 2, we can derive it from the first and second letters of the elemental name. Elemental name. Example is silicon. For silicon, it is what? Si. You see, sulfur is S. Silicon is Si. Silicon starts with letter S, but we cannot have two elements having the same symbol. It's not proper. It's confusing. That is why we have Si instead. Okay. Another example is helium. This is helium and it is what? He. We can talk of lithium. Lithium, which is what? Li. So, like I said, the first letter is usually in capital letter, then the second one is in small letter. Okay? So, number 3, we can say the first and any other letter of the elemental name. Okay, first and any other letter of the word elemental name. Okay, so in this case, let's give an example. Magnesium. We have magnesium. Magnesium is represented using letter Mg. Okay, we also have chlorine. This is chlorine, represented by capital letter C and small letter L. So you can see how it is. These are 3 examples, okay? So the 4th example, or the 4th way that you can derive these symbols is through their Greek or Latin names. Example is sodium. Sodium, if you call it, starts with letter S, but the symbol of sodium is Na. I'll have to clean the board so that I can be able to write what I'm trying to pass across to you. Okay? So now, I said number 4 is through the word, the Latin or Greek name. Example, we have sodium, whose Latin name is what? Natrium. And then the symbol is what? Na. The symbol for sodium is Na. Another one is your lead. Lead is known as what? Plumbium. And it is represented by letter Pb. We also have your potassium, represented with letter K from carium. We have gold, represented by letter Au from urium. We have silver, represented by letter Ag from argentium. So the list goes on and on. But these are the basic ways that the elemental symbols is what? Derived. Okay, so having established this, let's look at the first 20 elements. The first 20 elements. And the reason for looking at these first 20 elements is because in a lot of cases, most examples that are given in class during the first set of lessons are usually given using the first 20 elements. Is that clear? Okay, but there are so many other very important elements that comes into play when citing examples in classroom. But let's just deal with the first 20 elements here. Okay, so for the first 20 elements, we have a hydrogen as number 1. Hydrogen, I'll write them all out, then after that we'll fix their elemental symbols. Okay, we have helium, we have lithium, we have beryllium, we have boron, we have carbon, we have nitrogen, we have oxygen. Okay, we have fluorine, and we have neon. Okay, these are the first 10. Then the second 10, which is 11 to 20, we now have sodium. We have magnesium. We have aluminium. We have silicon. We have phosphorus. We have sulfur. We have chlorine. We have argon. We have potassium. And then we have calcium. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Okay, so for hydrogen, the elemental symbol is what? H. Helium, we have He. For lithium, we have Li. For beryllium, we have Be. For boron, we have just B. For carbon, we have just C. For nitrogen, we have just N. For oxygen, we have just O. For fluorine, we have just F. For neon, we have Ne. For sodium, we have Na. For magnesium, we have Mg. For aluminium, we have Al. For silicon, we have Si. For phosphorus, we have just P. For sulfur, we have S. For chlorine, we have Cl. For argon, we have Ar. For potassium, we have K. And for calcium, we have Ca. Now, everything I have said about how these elemental symbols were derived can be seen here. For those derived from the first letter, we have hydrogen, boron, carbon, nitrogen, oxygen, fluorine. And then we have phosphorus, sulfur. Okay? And we can say potassium, but we can put an asterisk there because it was gotten from the word Latin name. Okay? But still the first letter of the Latin name. Then for those gotten from the first two letters, we can talk about helium, we can talk about lithium, we can talk about beryllium, we can talk about neon, we can talk about sodium, but we can also put an asterisk because this is gotten from the Latin name. But we can talk about aluminium, we can talk about silicon, okay? We can talk about argon, we can talk about calcium. Is that clear? Okay. Now, for those that are gotten from the first alphabet or first letter and any other letter, we can talk about magnesium and we can talk about chlorine. Then, those gotten from the Latin names, we can definitely mention sodium and potassium. Is that clear? Is that clear? Okay, so now let's talk about compounds without wasting further time. Let's look at compounds. A compound is a pure substance. I'll prefer to just talk about it without writing on the board, but I'll repeat the definition so that you can write it on your own. Okay, a compound is basically a pure substance that is combining as a product of the combining of two or more elements. Okay, I repeat it. A compound is a pure substance that is formed by combining two or more elements chemically. That is to say that a chemical reaction is required for a compound to be formed. Is that clear? Now let's take water for example. Okay, So this is your water. Now, if we look at this chemical symbol or chemical formula of water, you would notice that two elements are involved: hydrogen and oxygen. Okay, then another thing that you can observe from this formula is this subscript 2. This subscript 2 is telling you the number of atoms of hydrogen that is in the reaction. That is, it is telling you the ratio by mass in which hydrogen and oxygen came together to form water. So this implies that the combining of elements to form compounds tends to happen by a fixed ratio by mass. If we don't have the same amount of a particular element in a given compound, then it is not the same compound. I'll give you an example. Now, we can also have something like this, H2O2. In this case, we have 2 atoms of hydrogen and 1 atom of oxygen coming together to form water. But in this case, we have 2 atoms of hydrogen and 2 atoms of oxygen. This is a different compound altogether, known as what? Hydrogen peroxide. And these 2 compounds have distinctive properties, both physically and chemically. They don't have the same properties. Okay? And this is reason why they are different compounds. Once you alter the ratio by mass of the elements that make up a compound, even if it's the same elements, automatically its identity changes. If you change the composition, that is the amount or the elements involved, then you have a different compound altogether. I'll give you another example. Let's take H2S. Now, we still have 2 atoms of hydrogen involved, just like in the case of water. But in this case, we don't have oxygen anymore. We have sulfur instead. So this now is known as what? Dihydrogen sulfide. Dihydrogen sulfide. Okay? Now, this is highly flammable compound. Why this is what? Used in extinguishing fire or flame. You can see they are completely different from each other. Is that clear? So when you change the amount of an element in a compound, you have completely changed the identity of that compound. It's no more the same compound. When you remove an element from a compound and replace it with a different element, you have a completely different compound as well. Is that clear? Okay, great. So now, having established this, let's now take a look at how the there's something I need to state here first. Okay, now when we talk about the formation of compounds, 2 elements can come together to form a compound. 3 elements can come together to form a compound. 4 elements can come together to form a compound, or even more than 4 can come together to form a compound. I'll give you examples. For example, we have NaCl, we have MgO, Okay, this is magnesium oxide. These are formed by what? Two elements, sodium and chlorine, magnesium and oxygen. Now we have cases where three elements can come together. Let's talk about sulfuric acid, which is what? H2SO4. In this case, we have hydrogen, we have sulfur, and we have oxygen coming together to form this compound. Let's talk about calcium carbonate. We have CaCO3. We have calcium, we have carbon, we have oxygen coming together. Okay, now let's talk about cases where we have four elements. Okay, this is NaHCO3, which is sodium bicarbonate. Okay, now we have sodium, we have hydrogen, we have carbon, and we have oxygen. Four different compounds, four completely different compounds coming together to form this. So, information of compounds, two or more distinct elements can come together to form that compound. Is that okay? Great. For the other thing I wanted to talk about, which is the naming of compounds, I think it is best to leave it for a separate lesson where we talk about how to name inorganic compounds, because the rules for naming inorganic compounds differ completely from the rules for naming organic compounds. So we would look at that of organic compounds when we get to organic compounds. So let's leave it at this for now. So based on what has been taught today, we have looked at pure substances, and we focused on what? Elements and compounds, which are the classes of pure substances. We looked at how the symbols are gotten. For compounds, the symbols are gotten by what? Getting or bringing these elemental symbols of the elements that make up the compound together, and then the amount of or the number of atoms involved in the reaction that gives us the chemical symbol of the compound. In the case of the elements, we looked at it as well. Okay, great. And for mixtures, we would look at that in the second part of this lesson. I hope you join us for that part. If you've not subscribed to this channel, please kindly do, and then click on the notification button so that when the next lesson comes out, you will be promptly informed. Thank you very much and have a lovely day. Bye.